Sir Arthur Stanley Eddington once said, "The universe isn't just more peculiar than we can envision, it is more peculiar than we can envision." And to be sure, the English astrophysicist was squarely in the most natural-sounding way for him. After all, we end up in the middle of a world that irredeemably rises above our brains with its size, intricacy, and worldly aspect, sprinkled with billions of cosmic systems, stars, and planets. The universe is managed by principal regulations that show that there are instruments and peculiarities that go past the restrictions of our ordinary encounters and our imagination. However, what dreamlike things are truly concealed in the unending scope of space? Or more, will we at any point be capable of figuring out the universe in its whole? There is no doubt that the universe, with its thousands and huge number of designs and incomprehensible profundities, can appear to be not just overpowering but also to some degree threatening. Yet, did you realize that feeling of dread toward the universe even has an official name? The feeling of dread toward the universe and its eminent bodies is known as astrophobia, cosmophobia, or even space fear. In addition to the alarming void, it frequently also refers to the secret privileges of the obscure. After all, we shouldn't disregard that from our natural point of view, we are simply able to see a little part of the super frightening, and we have only barely begun to interpret the secrets of the recognizable universe. No master understands what wondrous things hide beyond our grandiose view. However, what we truly do know is that even the developments right on our natural doorstep could barely be more alien. Just investigate the planetary ruler of the nearby planetary system. In addition to the fact that Jupiter is multiple times bigger than Earth, with a diameter of very nearly 143,000 kilometers, at the same time, our natural home would also fit 1,300 times into the enormous gas monster. Moreover, the Great Red Spot, a monstrous typhoon, chases across Jupiter, which even all alone effectively overshadows our blue home planet. And assuming the Earth were somehow to slam into Jupiter, it would be assimilated into its environment, burned, and melded with its gas mists and fluid metal, very much like a drop of water falling into the sea, and hence into its own obliteration. Furthermore, if the drop of Earth were to take note of anything of its journey simultaneously, it would be confronted with whip-wind velocities of many kilometers per hour before it finally stirs things up around the town mantle of the planet, coming into close contact with a planet-crossing ocean of shining fluid metallic hydrogen. Luckily, we are saved from this upsetting situation in reality, so right now we still have time and chance to remember another amazing truth. Until the mid-1990s, space experts didn't know whether different planets existed outside our solar system. Yet today we know better. Scientists have already identified over 6,900 exoplanets in more than 4,900 different systems, but this is only the smallest tip of the planetary iceberg. After all, recent evaluations suggest that another 100 to 200 billion planetary systems are still out there, and that's just in our Milky Way. But that's not all. Although official evidence of extraterrestrial life is still awaited, a recent study by the University of Nottingham presumes that upwards of 36 smart civilizations could already be prospering in our home system. And with the information at the back of our minds that the visible universe is estimated to contain 200 billion galaxies, everybody can compute for themselves the tremendous numbers of highly developed alien civilizations potentially growing, on paper. Of fiendish planets and heavenly monsters. Anyway, a look at the odd universes that have proactively been revealed in the depths of space shows that not each exoplanet can be thought of as a potential alien home. Take, for instance, HD 189733b, which, with temperatures of up to 3,000 degrees Celsius and wind speeds of 30,000 kilometers per hour, can without much of a stretch be described as an inestimable heater. The way that the heavenly body, which is around 64 light-years away, appears dark blue, in spite of this, isn't due to a gigantic stock of water but to the extremely sharp, small glass particles that race through the air at high speed. It is, therefore, not actually amazing that NASA formally referred to this extreme downpour of glass splinters as rules of dread. But these are just planets. However, if we let our gaze wander to the stars, the sparkling point in the atmosphere sung about in so many kids' tunes also turns into fearsome giants in our local solar system. the Sun is considered the proportion of all infinite things. No big surprise, since our source of warmth and existence, with a diameter of practically 1.4 million kilometers, is also altogether more imposing than any other heavenly body in our area. It alone contains, in all honesty, 99.86% of the total mass of our solar system. In a superordinate heavenly setting, anyway, and this is the surprising thing, the Sun is, in fact, quite ordinary, and it begins to shrink more and more when we contrast it with the other heavenly outgrowths of the universe. After all, what are 1.4 million kilometers compared to 3 billion kilometers, situated around 20,000 light-years from us in the star cluster Stephenson 2? The red supergiant Stephenson 2-18 is viewed as one of the largest known stars in the whole universe. And while its radius is estimated to be multiple times that of the Sun, it also has a volume 10 billion times bigger than that of our Sun. Anyway, it gets even more amazing when we take a closer look at the absurdly large structure in the star grouping Canis Major. In fact, we are looking at a radiant quasar here, a functioning cosmic core called TN618, which is believed to be an accretion disk of hot gases around a very massive black hole. Well, the term very massive is, in fact, an understatement. Truth be told, TN618 ranks first in the newly announced group of ultramassive black holes by NASA, a position it has actually earned with its own mass of 66 billion solar masses. However, it should be noted right now that other studies suggest a somewhat lower mass of just 47 billion solar masses. But what is undisputed, anyway, is the fact that the hyperbright quasar surpasses its home universe to such a limit that it couldn't even be noticed from Earth. Expressed in figures, this amounts to nothing other than the fact that the brilliance of TN618 is less than 30.7 Macintosh. In other words, it shines 140 trillion times brighter than the Sun. Peculiar matter and astronomical chemists, assuming we now also consider that the Schwarzschild radius of TN618 is estimated to be 300 cosmic units, which is multiple times the orbit of Neptune, the question rapidly emerges as to what inestimable construction might actually be bigger. The answer, nothing seems clear here. And if you like, it's even right after all, Bode's void is sometimes referred to as the Great Nothing. In detail, we are dealing here with one of the largest known voids, or, in other words, low-matter pits in the universe, which has an incredible diameter of 300 million light-years. By comparison, the diameter of TN618 is just 1/125th of a light-year. And while the tremendous designs of the universe are without a doubt striking, the cycles that occur on a somewhat smaller scale are no less bewildering. First of all, there is the material distinction of the universe. While matter on Earth usually has a solid, liquid, or gaseous state, 99.9% of the normal matter in space is present in something else entirely, plasma. This substance, consisting of free particles and electrons, is in a charged state. Past gas, which emerges, for example, when matter is heated to extreme temperatures, our Sun also presents itself as a larger-than-life chunk of plasma. Furthermore, as a heavenly chemist, since each second you watch our video, our mother star fuses around 600 million tons of hydrogen into helium. This, in turn, relates to the mass of 102 Great Pyramids, 1,812 Empire State Buildings, or, according to some estimates, practically all the fish in the world. And while the solar fusion engine is running continuously, it produces not just new elements but also tremendous amounts of energy and light particles, called photons, which take around 250,000 years to travel the 700,000 kilometers distance between the center of the Sun and the visible surface of the Sun. However, the photon journey speeds up in the following period because, in fact, the light then only takes about 8 minutes to travel the 150 million kilometers to Earth. But basically, the Sun not only turns on regular light, it also ensures that there is a colossal bang in space around the Earth when, from the solar wind, a surge of charged particles collides with the Earth's magnetosphere. It swirls the magnetic field lines into confusion, making them break and realign, shooting away charged particles. This sensitive presentation is called magnetic reconnection. And while we can't see it with our unaided eyes, its effects are sometimes visible. This is the case when some of the solar wind particles crash into oxygen molecules in the upper atmosphere, magically creating swirling auroras. Furthermore, you can make a subscription with only one magically twirling click. Happily, press your thumb now and click subscribe so you never miss another video from us again. We'll see you soon.